In this video, we want to go over our second review sheet to get us ready for the final exam. So first off, we want to go back and look at matrices here, and first start off looking at two things here for the first problem: adding two matrices and then also multiplying by a number. So first, let's multiply by the 3. So all that does is it multiplies everything in the matrix by 3. So that's 15, 3, -3, and 9. And then if we add a matrix, all we do is add corresponding elements. So we can use that to help us figure it out. So if we look at this 7 right here, we're going to get that 7 from just 3 plus x. So if that's 7, that's going to tell us our x is equal to 4. Now if we look at the bottom here, we also have this -1 in x, and that's going to give us this 1. So that also tells us that -1 plus x is equal to 1, and that also tells us x is equal to 4. So there's two different ways in this of getting our same answer. Now if we look at multiplying matrices, remember we multiply across a matrix and down the column. And you can do these on a calculator, but we're going to look at this one here first. We're going to have 3 times x plus, now I go across, 1 down times 5, 1 times 5, and that has to equal that number right there, which is 8. So this is 3x plus 5 equals 8, and you can see that would be x equals 1. Now in the next one, we want to find a inverse of a matrix. Now the only way to really find an inverse is to use the calculator. So let's go back to our calculator and talk about how we can do this on our calculator. So we're going to go to second matrix, we're going to go to edit, and then we're going to have to put in what is the dimensions of this matrix, and this is a 2 by 2, and my numbers are 3, -2, 1, and 4. And then we can get out of that. We go back to our matrix. We call matrix A, inverse is -1, and we hit enter. And instead of all those crazy decimals, I'm going to change that to a fraction. And so there is our matrix that we get on the calculator. I'll go like that, and we'll put it right there as our answer. Okay. Really, that's the only way to find that. Now, it's also true when we try to solve a systems of equations. We're going to go and use a matrix also. So first I'm going to go to edit. And if you remember, we're going to do something that we call a augmented matrix. So it's going to be a 3 by 4. So I put the numbers in going across the row, or across the equation into the first row. The numbers that go across into the second row. The numbers that go across into the third row, like that. So 1, 2, -1, 6, 2, 1, 1, 6, 1, 3, -1, 7. And then if you remember to find that, we go back to our matrix. We're going to go to matrix math, and we're going to scroll down to the RREF. So we do RREF of matrix A, and we hit enter, and that is what we get on our calculator that's going to tell us our answers. Let's put it into that RREF mode. So from there, we know that our answers are going to be that our x is 3, our y is 1, and our z is -1. All right, so to deal with the right triangle, we first have to figure out what is our hypotenuse. And if we do our a squared plus b squared equals c squared, it's a little different because our c is not at the right angle. So 121 plus we get the square root of 137. So what is the cosine of A? The cosine of angle A is adjacent over hypotenuse, which is 4 over the square root of 137. Now, for these secant and tangent, we're going to do those on our calculator. So if you want to find the secant of 4 pi over 3, remember you need to change your calculator mode to radians, which I have it in radians. And then remember secant is 1 divided by cosine of 4 pi divided by 3. And we get -2. And then to do tangent of 200, we have to go back, change our calculator to degrees, and then we can do tangent of 200, and we get that. So there is both of those. The big thing in doing on the calculator is making sure you switch the mode. Okay, that's the important thing, that you get the mode correct so you know how to do it. Okay, let me put that right here. Up here, you want to be in radians. To do here, you want to be in degrees. Now, as we get into solving a triangle here, let me go back and make sure my calculator is in degree mode. It is. So now, let's solve for angle C here. So to solve for angle C first, I need to find A. And to find A, I'm going to use the law of cosines. And the law of cosines is 8 squared plus 13 squared minus 2 times 8 times 13 times cosine of 51. Remember that this is squared. So once you put that in your calculator, you're going to have to take the square root of it. And if I do, I get 10.105. Now remember, be careful. If I wanted to find angle B is the largest angle. And you can't use law of sines to find the largest angle. Now, it doesn't ask me to find that angle B here. It asks me to find angle C, but just refreshing your memory on that, you can't use the law of sines to find the largest angle. So here is our angle C. So we get the sine of C over 8, the sine of 51 over 10.105. And remember, anytime you're solving for an angle, you have to use inverse sine. So I'm going to do our inverse any trig function. So 8 times the sine of 51. I'm going to divide that by 10.105. Then I'm going to do inverse sine of that. And I get 37.971. So I get my answer for my angle C is 37.971 degrees. Now, if I wanted to find angle B after that, I could then add them up and subtract from 180. Let's look at solving a trig equation. So we want to solve on 0 to 360. So remember, these have two answers. So if we draw our unit circle, sine is -1/2 is here. So I'm going to get one answer there, one answer there. And if it's a unit circle value, which this is, so we could do it on a unit circle, but if it's not, we have to do it by doing inverse sine of -0.5, and we get -30. So that tells us that this angle right here is -30. So our two answers will be then over here, if I come down 30, that would be 210. This is 210 over here. And then this one would be 30 less than 360, which is 330. Cosine of 0.75. Sine is the y coordinate. Cosine is the x. So here is my x, 0.75. I'm going to get that answer. I'm going to get that answer. This is not a nice unit circle value, so I have to do this on the calculator. I do inverse cosine of 0.75. I get 41. So that's my one answer, 41.1. Now to find my next answer, I'm going to come down that same amount. So I'm going to go back here, and really I'm just going to subtract from 360 to get 318.59. Graphing with trig. Remember, the number in the front is my amplitude. So in this case, my amplitude is 2. That's how high the peaks and valleys go. This number here is how far it moves up or down. So I am going to go up 1, which remember is 2 lines. The number in front of the x is my period. So this is 2 pi over just 1, so it's just 2 pi. And if I had another number in there in the x, x something inside, that would move it left or right. So I don't have that right now. So cosine starts at 2. It ends at the end of the period is at 2 pi. In the middle, it's at -2. In this first half, it's at 0. In the second half, it's at 0 there. Now, I'm going to take each line and I'm going to move it up 1 or up 2 lines. So it goes to there, goes to there, goes to there, goes to there, and the final one, you move it up 1 goes to there. And then we can connect the dots, hopefully maybe a little bit better than I am. And there is our graph of our function. Vectors and solving vectors. So first, let's draw a vector diagram. So when you remember, if we're not like doing polar coordinates or unit circle stuff, when we're doing vectors, remember this is 0 degrees, this is 180, this is 90, and so forth. So our first vector is a course of 300. So from 0, 300, comes all the way around over to here. There's our length of 30. 300 means that this angle is 60, or more importantly, this angle's 30. Then we go west 20 degrees south for 17. That means this angle is 20. This is 17. Now we need to draw our parallelogram. So I'm going to add my 17 there, my 30 there. Don't know if that's a great picture, but not using a ruler here. So we get to there is our result. That's not the greatest picture, but I think you can see what we end up with. So we end up with 30. Now the key to these problems is always finding this angle. And you remember next two angles, adjacent angles in a parallelogram always add up to 180. So this is 30 plus 20, so that's 50. And if I take 180 minus that, that is going to give me this angle here, which is 130. So now if I put this to find x into law of cosines, I'm just going to put the square root in right away. This is 30 squared plus 17 squared minus 2 times 30 times 17 times cosine of 130. And if you do all that, put it in your calculator, you get x is 42.494. Verifying or proving a trig identity. The first thing we want to do is, remember, you want to think about working on one side and one side only and using our fundamental trig identities. So in this case, we're converting everything over to the right on sine and cosine, so I'm just going to kind of rewrite this with sine and cosine. Tangent is sine over cosine. plus sine. Cotangent is cosine over sine. And right away I can see inside here before I even multiply, those go away. Now, if I multiply cosine times sine over cosine, the cosine is going to cancel. I just get sine of x. And then if I take cosine, distribute through times cosine, there I'm going to get just cosine squared. And that is what I was trying to get. So I have verified or proved that trig identity. And our last problem here deals with our polar coordinates. And the first thing you want to figure out, remember, is which ring is it on? 1, 2, 3, 4. So we have 4 for our -4, and I'm not sure what's happening with my computer here. So now we need our angle. So this angle right here is 120. So we have 4, 120. Or we could write that as 4, -240. Our other angle would be down here at 300. But then when we go back, that's going to be -4, 300. Or if I do that as a negative angle, it will be -60. So there are our answers for our polar coordinates. So that is our second review for the final exam. There's additional homework over this section's, the second part's review also, and then you will be ready for the final exam.